All right, good questions about radicals coming in. Let's take a look at these three just to get an overall idea about simplifying radicals. You know, if you go to your calculator and type it in, most calculators are just going to give you the decimal answer. And most of the time, that's not what you need. You need it in simplest radical form. So first of all, radical means this little square root symbol. So a radical is that square root symbol that we're looking at there. When we have to simplify it, we want to think of it in terms of the smallest numbers that we can. And so you want to sort of break this apart. Now, when I say break it apart, I mean, what can you multiply to get 125? And so it's not even. I can't divide by 2. 5 plus 2 is 7, plus 1 is 8. So it doesn't divide by 3 because 8 doesn't divide by 3. And so it ends with a 5. I know it's going to divide by 5. So think about what that'll be. 125 divided by 5 would be 25. 5 quarters is $1.25. So that's right. Okay. Well, how about these numbers? 5 is just 5, right? It's a prime number. And all that means is that the only thing that it will divide by is 1 and itself. It'll divide by 5. It'll divide by 1. So in other words, we're finished with a 5. But 25 we can break apart again, right? 5 times 5 is 25. So that's what we're kind of looking at here. When we look at this, notice that we have 3 5s. And so we're going to use this concept of a pair as a perfect square. And so we have 3 of them. So we have a pair of 5s here. And we have an extra like leftover 5 there. And so when we are simplifying radicals, just keep in mind that a pair is a perfect square and you're looking for perfect squares within this number. And so since we have one, 5 is that square root. And so we're left with a 5 underneath the radical that's still there. So this is the 5 underneath. This perfect square is 5 times 5 is 25. And so that perfect square of 25 is broken into 5 by 5 to create that perfect square. So that's where the 5 in the front comes from. So the square root of 125 is simplified to 5 times the square root of 5. So we would say that 5 times the square root of 5 or 5 square root of 5 is the answer to this question. All right, let's take a look at number 2. So when we look at this one, think about what you can multiply to get 30. Now, the interesting thing on this is that you might think of different things, right? So I'm going to write it a couple of ways. Let me scoot myself over here. Okay. So maybe you thought, oh, 3 times 10 is 30. Or maybe you thought, oh, 5 times 6 is 30. Or maybe you thought 2 times 15 or 15 times 2 is 30, right? Let me make that look a little bit more like a 2. Okay. So it's okay if you thought 3 times 10 or if you thought 5 times 6. That's my reminder to do something. So we're good. Or if you thought 2 times 15. Because when you think about, let's continue. Let's say we thought 3 times 10. Well, 3 is prime. The only thing I can do with 3 is multiply 1 times 3. So that doesn't help. But 10 is 2 times 5, right? That can break down into 2 times 5. 5 is just 5. That's prime. But 6 can be broken down into 2 times 3. And 2 is just 2, but 15 could be broken down into 5 times 3 or 3 times 5. Now take a look at the final answers for all 3 of these. Do you see how they're all the same? The order doesn't matter because you're multiplying. 2 times 3 is the same as 3 times 2. And so 3 times 2 times 5 is the same answer as 5 times 2 times 3 or 2 times 5 times 3. So all of that to say that regardless of how you factored or broke that down into its factors, you're going to end up with the same numbers when you're finished. Now, we needed pairs over here in order to simplify the square root. We have no pairs here. So let's just say that we went with 3 times 10 since it's written first. Okay. Doesn't matter which one you do. We have 3 times 2 times 5, and there are no pairs. That means there's no perfect squares. No pairs, no perfect squares. That means that the square root of 30 is already simplified. It cannot be simplified any more than that because it does not contain any perfect squares inside of it. Whereas 125 contained a perfect square. It had 25 in it, and the square root of 25 is 5. Okay, let's do one more. 1089, square root of that. That's a big old number. It's not even. That's no fun. I can't divide by 2. Let's see if I can divide by 3. So if I add the digits, 1 plus 8 is 9, plus 9 is 18. Yeah, 18 divides by 9. So that means it will, actually, that means it'll divide by 9, and it'll divide by 3. So we could do it either way. I was thinking of 3, so we'll do it like that. So let me pull up a calculator. I think I already have it open. Yeah. Okay. So let's do 1089 divided by 3. And the point of this is that we're not using the calculator to give us the square root answer. We're using it just to help us do the division a little bit faster. I know that you can divide. That's not what the point of this lesson's about, right? So now it's 3 times 363. Well, 363 is still a really big number. So 3 plus 6 is 9, plus 3 is 12, and 12 divides by 3. So I know I can divide by 3 again. So let's do that. 363 divided by 3 is 121. Okay. 3 just comes down, and this is 3 times 121. Okay. Well, 121 doesn't divide by 3 because 1 plus 2 is 3 plus 1 is 4. It does ring a bell, though, that is a perfect square, that is 11 times 11. Now, if it didn't, then we could try other numbers, right? You could do 121 and divide by 4. You get a decimal, so it's not a factor. It doesn't end with a 5, so it won't divide by 5. It won't divide by 6 because it didn't divide by 3. We could try 7, 121 divided by 7, and we get a decimal. I see that my word, where I had written is covering up that, so I want you to be able to see it. Okay. And then, so a decimal means that it doesn't work. 121 divided by 8 gives me a decimal, and 121 divided by 9 is a decimal. 121, well, divided by 10, I know doesn't work because it doesn't end with a 0. And then, so if you hadn't thought of 11, then there you go. 121 divided by 11 is 11. All right. So take some trial and error sometimes with these to make sure that you're good. So there's a pair. And let me bring down the other numbers. There's a pair of 3s. Now, if I have 2 pairs, then that means that this is 3 times 11, because a pair is a perfect square. So that means this was really a 9. Square root of 9 is 3. So there's the 3. This was the square root of 121, which I know is 11. So 3 times 11 is 33. So that means that the square root of 1089, that's a perfect square. You can see it over here if you want. It comes out nicely that it is a perfect square. It's exactly 33. And so that means there's nothing left under the radical, under that little square root symbol. And so there's not one in the answer. Okay. Now you can see these all seem to act very differently. Hopefully you're starting to see a pattern in how these work. Mindset's really important, thinking, okay, this is confusing, but that doesn't mean I can't do this, right? It doesn't mean this is impossible. It just means I probably need some more practice with it. All right, so we'll get some more practice as we do some more of these. I hope this was helpful.